Now that we have defined some special terms for a regular polygon, we will talk about how we find the area. To find the area of any regular polygon, it would be equal to 1/2 times the length of your apothem times the perimeter of that regular polygon. In our first example, we're going to find the area of a regular hexagon when I know the length of the radius. The first thing we want to do is draw our regular polygon. As in the past, we just need to draw enough of the polygon so that we would be able to work with a radius and an apothem. The first thing I want to do is go ahead and draw my radius. So we know that the radius is a segment from the center of our regular polygon to a vertex. And this radius is 6 square roots of 3 centimeters. We will also need to draw our apothem, and it's perpendicular to that side to give me a right triangle to work with. And since this is a regular hexagon, we know that this angle will be 60 degrees, and now we have a 30, 60, 90 triangle. We're wanting to find the area, which is equal to 1/2 times the apothem of our regular polygon times the perimeter of this regular polygon. And if you notice, I don't know my apothem, so I'm going to have to find it. And in order to do that, we're going to use our special right triangle ratio, which is 1, we know that it's 1 to the square root of 3 to 2. Looking at my diagram, 6 square roots of 3 is the hypotenuse, so it would go here. The apothem is my long leg, and it would go here. Then we would cross multiply. When I cross multiply, 2 times a is 2a, and that would equal 6 times the square root of 3 times the square root of 3. This would give me 2a equals 6 times 1 is 6 times square root of 3 times square root of 3 is 3. So we would have 2a would be equal to 18, making a equal to 9. So now we know that our apothem is 9. But we also, in order to find perimeter, we need to know the length of a side. Remember that the apothem is going to bisect this side. So if I could find this piece, this would be the same, and then I could find the length of my side by using segment addition. X happens to be my short leg. So that's going to go under 1. So to find x, I would cross multiply 2 times x, which would give me 2x, and that would equal, when I cross multiply this way, 1 times 6 square roots of 3 is 6 square roots of 3. Dividing both sides by 2, I'm going to get x would equal 3 square roots of 3. So this is now 3 square roots of 3. but I need the length of the whole side. Then this is also 3 square roots of 3. Making my side length 6 square roots of 3. Now I have all the puzzles we need to find the area. So the area would equal 1/2 times my apothem, which is 9, times we need to find the perimeter. And we know the perimeter is equal to the length of a side, 6 square roots of 3, times the number of sides, with it being a hexagon, is going to be 6. So putting everything in the calculator, we would now have 1/2 times 9, and then 6 times 6 square roots of 3 would give me 36 square roots of 3. So this area would equal 1/2 times 9 times 36 square roots of 3, and that would be 162 square roots of 3, and our unit of measure is centimeters, so it would be centimeters squared. So the area of a regular hexagon with a radius of 6 square roots of 3 centimeters is 162 square roots of 3 centimeters squared. In example number 2, we want to find the area of this regular triangle when we are given an apothem and a side length. We know area, once again, of any regular polygon is 1/2 times the apothem times the perimeter of that polygon. If you notice in this particular problem, we could draw our radius because it never hurts to go ahead and draw it. However, based on the formula, we have everything we need. We have an apothem of 10 and we have a side length of 20 square roots of 3. So here, we don't really have to find anything extra. We're just going to substitute the values into our formula. So we have 1/2 times the apothem of 10. And again, to find the perimeter, we have to take the length of a side. And since all sides are congruent, we can just multiply by the number of sides, and that's going to be 3. This would give me 1/2 times 10, and then 3 times 20 square roots of 3 is 60 square roots of 3. Whoops, getting a little sloppy here, Mrs. Harper. So 60 square roots of 3. And using our calculator, when I take 1/2 times 10 times 60, I get 300. And then we have square roots of 3. There are no units of measure on this one, so you can leave it, or you can put units squared. So the area of my regular triangle would be 300 square roots of 3 units squared. Now looking at example 3, if you notice here, we want to find the radius of a regular quadrilateral when I know the perimeter. So we're going to go ahead and draw our regular quadrilateral. And a regular quadrilateral is just another name for a square. We're looking for our radius, so we'll go ahead and draw the radius. This is what we want to find. And we know the perimeter. Since all sides are congruent, to find the length of a side, I would just take the perimeter, which is 36, and divide it by the number of sides, 4, so that each side length now is 9 feet. So my side has a length of 9 feet. I'm going to draw the apothem to help me now be able to work with a right triangle. And when I draw the apothem, we know that it bisects a side. And when I draw the radius, we know that it bisects the angle. So this is going to give me a 45, 45, 90 triangle to work with. When we work with our 45, 45, 90 triangle, my ratio is 1 to 1 to the square root of 2. If the apothem bisects a side and my side has a length of 9 feet, then I know that this half of the side is 9 divided by 2, and we just leave it as our fraction. So working with my special right triangle, the leg is 9 halves, and I'm actually looking for the radius, which with respect to my right triangle is the hypotenuse. When I cross multiply, 1 times r gives me r, and then 9 halves times the square root of 2, which I will just put over 1. Now we're going to multiply. 9 times the square root of 2 is 9 square roots of 2, divided by 2 times 1, and that's 2. So my radius would equal 9 square roots of 2 halves feet. So we've now worked with examples on how to find areas of regular polygons, as well as how to find a missing side length, an apothem, or a radius. If you have any problems, feel free to contact me and we can work through this together.